our next keynote, which is going to be on revenue NSW AI algorithm, we're going to be joined by Kathleen Mackay, the Chief Digital Officer and Executive Director at Revenue NSW Department of the Customer Service, Australia. Well, Kathleen has a lifelong passion for technology, and her mission is to create productive, digitally enabled workplaces that enable staff to thrive and deliver best-in-class results for customers. So, ladies and gentlemen, it is now time to call Kathleen on the stage and screen. With this, over to you.
So Kathleen Mackay, Chief Digital Officer at Revenue New South Wales. And I've got about 15 minutes today, and I'll hopefully get a time check when I've got 5 to go, just to give you an insight into how we use AI and specifically machine learning to determine relative probability of a customer being vulnerable. And I'll talk a bit about what is vulnerable, how this model works, and what does it mean for us from a business and a customer perspective. And if you do want more depth on this and we don't cover it today, please feel free to reach out afterwards. So I'll give you an overview of Revenue New South Wales. So Revenue collects state taxes, duties, administers fines, resolves debt. We also run the Home Builder Scheme and the Home Buyer Grant. But it's fines and fines debt that we'll zoom into in this presentation. And just to set a bit of context before we get into just vulnerable customers and our handling of vulnerable customers, I will just say that New South Wales is very fortunate to have some really progressive legislation around fines administration. We've got options for customers like payment plans for everyone, review of a fine that can occur at any time, and there's no interest applied on any fines debt. So under the Fines Act, it does specify actions that Revenue can take to recover money that has not been paid by customers where it's owing. So that can include, well, firstly, you get a penalty notice, then you get a reminder, then that fine goes enforced. But some of the sanctions can include driving licence restrictions, seizing property, although we very, very rarely do that, and garnishee, which is where we can direct your bank to remove money from your account or direct your employer to remove money from your wages in order to resolve your fine. So whilst these options are available, they need to be used with real consideration. Is it a reasonable action to be taking in the circumstance, given what we know about that person? And here's where data, but more importantly, machine learning comes in. So let's just talk about what is a vulnerable customer. Now, it's often not just one thing, but multiple things, multiple data points triaged together to triangulate this. Could be experiencing health issues, financial issues, domestic hardship, homeless or nearly homeless, involved in the criminal justice system in some way, or young person as in a minor or an elderly person. But it's a combination of all these data points together that gives us the most insightful information, and this isn't an exhaustive list at all. So Revenue has approximately 3.4 million customers, and there's about 46,000 identified as vulnerable, and that's just about over 1%. And the vulnerability of an individual is not something that's stagnant. It changes over time as we get more and different data, and as the customer situations evolve. So most of us can manage our fines. We get them, we pay them. We're not always terribly happy about it, but generally we know we've done the wrong thing and we resolve it. We pay it, we move on. However, if you are living out of your car, if you're unable to get any income, your top priorities are not your fines. Your top priorities are putting food on the table and shelter over your head and your family's head. So the cycle of disadvantage can accelerate where government isn't assisting people who need help the most. So what's the problem that we're solving here? Prior to implementing this vulnerable prediction model, we have a set of steps and a process for fines administration that we step through. Very similar collection processes would apply to everyone. Now, though, we can figure out who is vulnerable, on a probability scale at least, and then we can redirect those customers to a way of working and a way of engaging with us that will help them resolve their fines. Because the bottom line is that it's very ineffective for government to go chasing debt with certain recovery steps when people don't have the means to pay. So if we look at the next slide, which is just benefits of accurately predicting vulnerability, you can see on the bottom, left to right, that we've got 0% probability of being vulnerable at one end and 100% at the other end. And what you can see here is that we've assigned a probability score to people, and we set a threshold at about 70%, so that's 2/3 the way to the right there. And we say 70% threshold, we're going to determine those people are vulnerable and the others are not. And that's sort of operational reasons why we determine it at 70%, but it's for the reasons that you can see on the graph there. As the prediction for vulnerability increases, you can see collection rates really drop. And that makes sense, right? Because people don't have the means to resolve those fines. And average debts are higher. That's those red bars. You can see it going up there. So early identification of vulnerable helps us work efficiently because we direct our resources in Revenue New South Wales and the rest of government in the right direction. The message we want to give vulnerable people who are struggling is that we are here to help. We've got options available. We can cease standard recovery actions, and we can redirect to something like a work and development program or other legal aid or other legal service assistance. And our teams support customers that have a raft of different life experiences, everything from domestic violence to homelessness, financial abuse, housing insecurity. The team are Lifeline trained, and they're very good at helping people from all walks of life and all situations resolve their fines. So let's talk a little bit about technology and training data. So we use a mix of open source and scripting languages that most analytics teams will have access to. And I think that's one of the real wins of this use case is that we're not really using anything fancy. These tools are available, quite easy to get your hands on. I think the cleverness is in how we use the data to solve the business problem that we have. So we've tested different types of machine learning models and also implemented them in different languages to see what best meets our needs. And essentially the requirement that the team worked on is we want to detect people, detect customers who look like the people our staff have told us are vulnerable. So we're mirroring the ways of thinking that a human would do it, but on a massive scale. So how do we validate results? We use 66% training, 33% evaluation method, take 100% of a data set, 66% is used to train the model, the other 33% is used to validate the result and check the accuracy. So it's supervised learning, and the team do use confusion matrices to figure out true positives, true negatives, false positives, false negatives. And then we also do a human check. So that's our subject matter expertise staff in the fines and debt team that often have done this for many years and are very practiced. They do a human check, and an analytics team check the accuracy of the model and train it on the data sets about every 4 weeks and compare that to baseline. So what are the challenges? Well, not all data sets in government that could be useful can be shared with us lawfully. And the other challenge is that data about an individual may not come to us in real time. And even if it did come to me in real time, did it come from the referring agency in real time? And the other challenge is just that vulnerable people may not be interacting with government. They might be isolated, they might be on the fringes. We might just not have enough information about them to accurately predict their situation. So whilst the model's technically accurate, I can't say that we identify every single vulnerable person who interacts with us because we just don't have the data. So the model predicts who is not vulnerable very accurately, about 99%. And that's in general because of the huge size of data that we've got, so 3.4 million total customer base. And it would be better, I think, as you said, with more data. But we do get false negatives. So we class people as having a lower probability of vulnerability when actually they are higher probability of being vulnerable. And we will look at that if we have time just in the last few slides as a case study. But it's just simply we don't have all the information on all of our citizens all of the time. Now, our results are explainable in the way that we can extrapolate from the algorithm, essentially like a decision tree that tells us sort of step by step, can be read by a relatively lay person exactly what's happened. Our mitigation against bias is really to look carefully at the information that we're actually putting into the model, and I'll go into top model attributes in a moment, but also it's the size of the sample size of the actual sample data. So in terms of top model attributes, here's just a selection. We have approximately 23 attributes that we use that are demographic in nature. You'll notice that we're not using gender and we're not using ethnicity. Phone contacts, that gives us an indication of whether the customer is able to self-serve and manage their fines on their own, or whether they've been reaching out to us for support in the past. Serious fines can be an indicator. Installment amount, you can pay your fines off over time. But where we see people requesting to pay just a very small amount, it gives us an indication that their income doesn't support a greater payment frequency or amount, therefore potentially vulnerable, and so on and so on. So since Steve Brady presented last time, we have added the socioeconomic index for areas. It's basically relative social advantage or disadvantage based on postcode. So we'll just quickly go through a case study. This is Rowan. He's 34 years old, unemployed. Our postcode information tells us he lives in an area of relative disadvantage. He incurred 6 parking-related fines way back in 2008, which he paid in full without issue. More recently, though, he's incurred another 16 fines, but more serious offences now totalling 4,500. He wants to achieve being debt-free, not being perceived as a criminal, retaining his driving licence and maximising his opportunities in the future. And if we just look at the timeline, this basically sets it out. And really what you can see is in that 2016 to 2019 timeframe, we're building up a picture that Rowan is starting to get into some difficulty. And therefore, we've moved him from being in the not vulnerable to the vulnerable because his prediction scores increased to 75% likely to be vulnerable. And therefore, where you see that tick is where we've redirected Rowan to a work and development order program where he can resolve his fines through either medical treatment or counselling, mentoring, and so on. So it's set him up to have an opportunity to move forward more positively. So I'll just wrap up now. I'd like to give a big shout out to the revenue analytics team and the fines and debt operations team who have worked together really well to get this working. Because not only does this model mean that we're better able to direct government resources into the place where we add the most value, it most importantly means that those customers who are in need and do need help are spared the pain of recovery actions that aren't appropriate for their circumstances. So yes, we use AI to protect people, and we're really proud of that. Thank you.
Thank you so much, Kathleen, for that amazing keynote on revenue NSW AI algorithm.